Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session of mechanical properties of fluids, so we discussed about the equation of continuity and the Bernoulli's principle, right? So today we are going to deal with the lecture number 5. So where in lecture number 5, so we'll cover the same Bernoulli's principle based questions and the Venturi meter and the velocity of efflux. These are our main objectives for the today's session. So as usual, I just need your attention for the next 1 hour, guys. You just have to complete this lecture in one stretch, okay? And at the end of the lecture, it's very important to prepare your own short notes. And the competitive examinations are around, so the dates were announced, so please gear up your preparations. Those students who are in class 12th now are the droppers who are following the Nexus Batch. So I'm kindly requesting you to gear up your preparation, okay? So complete the backlogs, so prepare your own short notes of every chapter and revise them daily. Do the previous year questions and do some extra questions, practice questions, and attempt mock tests. So analyze yourself time to time and change the preparation strategy. So in which subjects you are struggling and in which areas of a particular subject you are struggling. So these are all the measures that you have to take yourself, okay, and analyze yourself and change your preparation strategy accordingly, okay guys. So this is the high time, so where you have to spend the quality time in learning. So if you are spending 6 hours or 7 hours, so but you are not showing any output, so that's 6 hours spending or 7 hours spending is useless. So spend the quality time. So if you are sitting for the 3 hours or 4 hours at a stretch, so show some quality, spend some quality time there. So learn the concept, prepare your own short notes then. So do the questions, attempt it like a test. So whether it's a practice sheet or DPP, whatever it is, attempt it like a test. And so check how many questions you are able to do, whether you are able to solve the previous year questions of a particular chapter or not. Okay, are you able to remember the shortcuts? Are you able to remember the orders? So are the theory part, so whatever the shortcuts are there, are the in biology or so chemistry, so the theory parts, many orders you have to remember. So whether you are able to remember them properly or not. So all these things you should do by yourself, guys. So analyze yourself time to time. Clear? So this is a very crucial period, so don't waste your time. So I'm kindly requesting, so don't spend your quality time on some other things which are unnecessary. So you'll get lot of time after your exams. You can spend time with your family then, so you can spend time with your friends then. So but now, so avoid these things. So spend time with the family, that's fine, but allot some time for the studies also. Major time for the studies and some time for the family this time, because the dates were announced, so lot of people are preparing. So droppers are there and regular students are there, so you are in the competition, guys, okay? Just understand and proceed. Chalo. So let's go for the today's lecture. So let's start with the Bernoulli's principle. Already in the last session we discussed about the Bernoulli's principle, so where the equation of continuity is applicable, right? So for the steady flow, so the equation of continuity, where the equation of continuity, so what's the equation of continuity says? A1 V1 is equals to A2 V2. So A1 V1 is equals to A2 V2, which is also called actually the rate of flow, right? And then, so let's suppose this is a tube which is having different cross-sectional areas, A1 here and A2 here, the area A1 here and the area A2 here, and two different cross sections are at two different heights from the horizontal surface or the ground. So then I can write, so the Bernoulli's principle, it's actually based on the conservation, law of conservation of energy. It's based on the law of conservation of energy, law of conservation of energy, right? Chalo. So now, so we can write here, so what's the formula we learned? So the potential energy per unit volume, kinetic energy per unit volume, and pressure energy per unit volume is going to be constant. So the pressure energy per unit volume, potential energy, kinetic energy per unit volume, and potential energy per unit volume, so is going to be constant. That means the total energy per unit volume. So we can say this is a pressure energy. Just I am recapping. So pressure energy per unit volume, and then so kinetic energy per unit volume, and then this one potential energy per unit volume. This is a potential energy per unit volume. So which is totally, it's a total energy per unit volume. We can write it as total energy per unit volume is going to be constant. That's why it's a law of conservation of energy. So you can also write this equation as, so the P1 plus half rho V1 square. At this cross section, the pressure is P1. So and kinetic energy per unit volume is half rho V square plus, so the potential energy rho G H1. This is at a height H1, and this side, so the pressure, let it be P2, and then half rho V square, half rho V2 square plus, so rho G H2, right? So this is a Bernoulli's principle we have discussed in the last session. Clear, guys? So now let's go for the questions. So this question I gave it as a homework, so hope you guys solved. So if you are not getting, just follow the procedure here. So water is in streamline flows along a horizontal pipe. So the pipe is horizontal, right? So then with non-uniform cross section at a point in the pipe where the area of cross section is 10 centimeters square, and the velocity of water is 1 meter per second, and the pressure is 2000 Pascal. So then pressure at another point where the cross sectional area is 5 centimeters square. So first it's a horizontal pipe. Okay, so before solving this question, I'll write one more statement. See, so this formula, so we can write it for the horizontal pipe. For horizontal pipe, so what's the concept? The potential energy remains same. The H1 will be equals to H2. So the H1 is equals to H2 is equals to H, right? So then I can write, so the P1 plus, so half rho V1 square plus, so rho G H1 is equals to P2 plus half rho V2 square plus rho G H2. So here H1 is equals to H2 is equals to H, because the pipe is at the same horizontal level. So here let's suppose the cross sectional area of the pipe is different, but it is at the same horizontal level. So it is at same horizontal level from the ground. So this is the height. So the same horizontal level. So this height and this height both are same. So in that case, I can cancel P1 plus half rho V1 square plus rho GH. In place of H1, I am writing H is equals to P2 plus half rho V2 square plus rho G H2. Okay, and then in place of H2 you can write H. So rho GH gets cancelled. So we can use the equation P1 plus half rho V1 square is equals to P2 plus half rho V2 square. Here the potential energy per unit volume, so will get cancelled on either side in the horizontal pipe case. Okay, clear, guys? And one more thing that you have to remember, so wherever the cross sectional area is less, so the velocity is more. So wherever if the cross sectional area is less, so the velocity is more. So if the velocity is more, the pressure will be less. Remember this point always. So if the cross sectional area is less, the velocity is more. So if the velocity is more, the pressure will be less. So if you consider this cross section, so here the area A1, so here area A2. A2 is greater than A1. In this particular case, A2 is greater than A1. So I can write, so the V1 is greater than V2. Obviously, wherever the area is less, so the pressure will be more, right? So then, and wherever the velocity is more, so the pressure will be less. Wherever the velocity is more, so the pressure will be less. P1 less than P2. So this relation you can remember, guys. So important. Clear? Chalo. So now understand this question. So what's the question says? Water is in streamline flows along a horizontal pipe. So that means we can use the Bernoulli's principle, where P1 plus half rho V1 square is equals to P2 plus half rho V2 square itself. So with non-uniform cross-sectional area, so at point pipe where the cross-sectional area is 10 centimeter square, the other side it's a 5 centimeter square. So the pipe is of different cross-sectional area. So let's say this is a horizontal pipe, right? So this is a 10 centimeter square. This is not minus, this should be 10 centimeter square. So then, so this is 5 centimeter square. So let it be area A1 and let it be area A2. First identify the given information properly. And so the velocity of water at this place, so the velocity of water at this place V1 is equals to 1 meter per second. Fine. So then the pressure is, here the pressure P1 is equals to 2000 pascals. Fine. So then the pressure at another point where the cross-sectional area is 5 centimeter square. So one thing you should understand, here cross-sectional area is more, so that velocity will be less. If the velocity is less, so the pressure is more here. If the velocity is less, pressure is more. So here in this particular case the cross-sectional area is less. So here the velocity will be more and the pressure will be less. So can you rule out some options? Here the pressure, here it is 2000, and here the pressure should be less than here, because the here velocity is more. So here, sorry, here velocity is less, pressure is more. Here velocity will be more, pressure will be less, right? So that means the pressure at this place is 2000. Obviously the pressure it's which we are going to calculate here should be less than 2000. Should be less than 2000. So can we cancel out the option A directly? So one option you can rule it out, right? And it cannot be equal also. You can rule this also, because the cross-sectional area is not same. So you can go for the option 3 and 4. We have only 2 options now. So now see here the pressure at another point where the cross-sectional area. So first what I'll do is, let's apply the equation of continuity. Let's apply the equation of continuity, where A1 V1 is equals to A2 V2. A1 V1 is equals to A2 V2. So what is cross-sectional area? So this is 10 centimeter square. What is the velocity here? 1 meter per second. So see, if you want, you can convert it to centimeter square to meter, meter square, 10 to the power minus 4, your wish. So velocity 1. So which is equals to second cross-sectional area 5 into, again I am writing 10 to the power minus 4. So 10 to the power minus 4 gets cancelled. Or else you can cancel centimeter square you can cancel, your wish. So then I can find what is V2. So 10 to the power minus 4, 10 to the power minus 4 cancel, 5 ones are 5 2s are. So I can write here V2 is equals to 2 meter per second. So that's what I said. If the cross-sectional area is more, velocity will be less. If the cross-sectional area is less, velocity will be more. Here at this point we got the velocity V2 now, which is 2 meter per second by the equation of continuity. Now, so let's apply the Bernoulli's principle. So now the Bernoulli's principle for the horizontal pipe. So let's apply the Bernoulli's principle for horizontal pipe. For horizontal pipe. Okay. So what's the formula that we can write? So the P1 plus half rho V1 square is equals to P2 plus half rho V2 square. So P1, so the pressure at this cross-sectional area I got, they gave it in the question, 2000 A plus half into, so here the what is the liquid that they mentioned? Fluid. So water is in streamline flow. So water density, so let's take in meter per second only, because the velocities are in meter per second we got, and the pressure we are taking also in SI units, Pascal. So that's why take this as in 10 to the power 3. And what is V1 square? So the velocity V1, so they gave it in the question, 1. So 1 whole square. So the pressure P2 I have to calculate, yes, plus half. What is rho? Again water, 10 to the power 3 into, so what is V2 square? 2 whole square, right? Chalo. So then I have got here, so 2000 plus this is 1000 by 2, 500. Yes, so 2000 plus 500, this is 2500 is equals to P2. So here 1 2 gets cancelled, so plus, so this is 1000 into 2, so 2000. So P2 will be equals to 2500 minus 2000, so where we get P2 is equals to 500 pascals. Yes or no? So the P2 will be equals to 500 pascal. So the option 3 and 4, so I have got 4. Done. Clear, guys? So just by analyzing the basic concept, you can rule out 2 options. Okay, done. Clear? Sure. So let's move for the next question. So what's the question says? Water falls from a tap. So with cross-sectional area A0, this is not A0, A0 it is. So 4 meter square. So an area 1 meter per 1 meter square. A, okay. So here the area is 4 meter square. Here the area is 1 meter square. Okay. So h is equals to 2 meters. So the velocity v is. So the velocity v is. Okay, fine. So chalo. So first here the water they are considering. So the streamline flow. In this particular case, so the flow that they are considering is a streamline flow. The water coming from the tap. So in this particular question, so you should consider the streamline flow. Okay. Yes. So when the streamline flow happens, what happens? So from the tap, so the water comes with a wider width. So first they come with more width, and then as they come down, so the width decreases. Have you ever observed? So let's suppose water is flowing from the tap, so smoothly, no turbulent flow, like not complete tap is on. So let's suppose some tap is on, so then the water will have the streamline flow, and at the near the tap, so the cross sectional area will be more, and as it comes down, so the cross sectional area decreases. So this we have observed. So the same flow they are considering. So here the flow is like this. So here the cross sectional area decreases like this. So the cross sectional area decreases like this. Here the area is A0, here the area is A, here the velocity is V0, here the velocity is V. Okay, first we can, as a streamline flow, first we can apply the equation of continuity. Let's apply the equation of continuity. So let's apply the equation of continuity. So what we can write? So the A0 V0 is equals to A into V. A0 V0 is equals to A into V. So here what is the A0 that they gave? 4 meter square into, so what is the velocity V0 that they did not give? So the cross sectional area A is 1, which is equals to V. So I can write V is equals to 4 V0. So let it be the equation number 1, right? Chalo. So the first basic thing is, so here they are asking what is the velocity V. So can we cancel out any options? So no, let's, because we don't know what is the V0 here. If we know V0, so we can cancel out some options. Okay, no problem. So V is equals to 4 V0. That's fine. So now let's apply the Bernoulli's principle. Let's apply the Bernoulli's principle. Okay. So in these tap questions, so the major hint that is, so the pressure, so that you should consider here the atmospheric pressure will be there, and at some height the atmospheric pressure will be there. So when you are writing the formula, the Bernoulli's principle formula, so generally it is P1 plus half rho V1 square plus rho G H1 is equals to P2 plus half rho V2 square plus rho G H2. Yes. So here the pressure P1 and pressure P2 is equals to P atm. So the atmospheric pressure P1 is equals to P2 is equals to, So the atmospheric pressure, P atm. Okay, so because the water is coming out from the tap, so they are not flowing in the tube. So for the water which is coming out from the tap, so what is the pressure on that water when it comes out from the tap? Only the atmospheric pressure. And even at some height, so what will be the pressure? Only the atmospheric pressure will be there. So then I can write here, so P1 in place of P1, so I'll write P atm plus half rho V1 square plus rho GH1 is equals to, so P2 is P atm plus half rho V2 square plus rho GH2. So here P atm and P atm gets cancelled. Done. Chal. So now I have got half rho V1 square plus rho GH1 is equals to half rho V2 square plus rho GH2. So this is a second equation that we got. So now can we cancel out anything here? Can we cancel any terms? So the rho is for the same water. So we can cancel rho in every formula. So then I have got here, so half V1 square plus GH1 is equals to half V2 square plus GH2, right? Chal. So then let's do the basic calculations here. So I'm taking the LCM there. So the LCM is 2. So V1 square plus 2GH1 is equals to, so 2 is the LCM, so which is V2 square plus 2GH2. So 2 gets cancelled. So I'll write, so V, yes, fine, rho GH1, rho GH2. So it's a horizontal pipe. The height is not okay. So see here. So the thing is, let me do one more assumption here. So that is, so let's consider this is at the ground. The bottom point I am considering here is the ground. Okay. So that means the H1 is equals to H. This height H1 will become H, and then this is the H2, right? So the H2 is on the ground itself. So I am considering it as 0. So in place of H2, so let me write the equation again. So V1 square plus 2GH1, H1 is H I am writing. So and then V2 square plus, so this 2G into H2 is 0 because it is on the ground itself. Okay. So chal. So now, so which is equals to V1 square plus 2GH is equals to V2 square. V2 square. So here that means we can write the V2 square, the velocity at the bottom at some height is equals to, so V1 square plus 2GH. So have you seen this equation anywhere? Have you seen this equation anywhere? This is nothing but motion under gravity. V square is equals to U square plus 2AS. So that means if the tap water is having the streamline flow, so in that particular case, if you have to find the velocity after some height, so you can simply apply the equation of motion. Equation, the motion under gravity equation you can apply. Okay. So now I need what I need. So what's the question they said? So what is the velocity V? We need the velocity V we required. So this V2 is nothing but V square. What is V1? V1 is V0 square. So V0 square plus 2GH. So let me do it in the next slide better. So here V2 square is equals to V1 square plus 2GH, right? Done. Now what is V2 square? V. So V square is equals to, what is V1 square? V1 is V0. So plus 2G height H. So let's do one thing. So in place of this V0, because we need only V, they are asking find the velocity V, right? Then the velocity V is. So let's eliminate this V0. How do we eliminate this V0? From here, V0 is equals to, shall I write V by 4? V0 is equals to V by 4. So let's substitute that here. So V0 is equals to V by 4 whole square. So plus 2GH. So now do the calculations. So here V square is equals to V square by 16 plus 2GH. So from here I can write, so V square minus V square by 16 is equals to 2GH. I brought it to this side, and then 16 is the LCM, so it goes 16 V square minus V square is equals to 2GH, right? So which is 15 V square by, so 16 is equals to 2GH. Done? Yes. So now I need V square, right? So V square is equals to 16 by 5 into 2GH. 16 by 5 into 2GH. Let's substitute the values. So 16 by 15, not 5. So 16 by 15 into 2 into, so G value they asked us to take 10 in the question. So they did not mention. I'll take 10 approximately into, so what is the height H? So the height H is 2 meters. So let's write this is 2 meters. Yes, calculations. So now 5 3s are 5 2s are. So then 16 into 2 32, 32 into 2 64, 64 into 2 128 by 3. So this is V square. So now, so V square is equals to, I got, so 3 1s are, 3 4s are, and 3 2s are, so 2 0, so 42.66 something like that we get. So V square is equals to 42.66 something like that. So from here the V is equals to square root of 42.66. So I know that 6 square is 36, 7 square is 49. So something around approximately I'll write 6.5 meter per second, close option. So we can choose, first check the option so that you'll get the idea. 6.5 is there, so you can choose the 6.5. Clear guys? Understood the procedure? Everyone? So for the tap questions, the first thing is, even if they don't mention in the question, consider the flow is a streamline flow. Okay, and the second thing that you have to consider is, so when the water comes out of the tap, so the only pressure that acts is the atmospheric pressure at the top and at some height H, right? So apply the equation of continuity as it is streamline flow, and apply the Bernoulli's principle. So the pressures gets cancelled on either side, and this equation you can directly remember. Or for the tap questions, directly to find the velocity at some height, you can apply the equation of motion under gravity. Equation of motion under gravity. So this one. So V square is equals to U square plus 2GH. Formula you can apply. Done guys? Chalo, good. So we have got one more slide, not required. So chalo, so try this question on your own. So let's try this question on your own. So what's the question says here? Water from a tap emerges vertically downward with an initial speed of 1 meter per second. So the cross-sectional area of the tap is 10 to the power minus 4 meter square. Assume that the pressure is constant throughout the stream of the water. See here in the question they mentioned. So even if they don't mention for the tap questions, you should consider the pressure is uniform. Okay, the pressure is constant throughout the stream of the water, and the flow is steady. So that means streamline flow. The cross-sectional area of the stream 0.15 meters below the tap. Okay, fine. So same question. So this is the tap. So water is coming from here. So how the water flows? Like this. So this is the water flow. So then here some cross-sectional area and here some cross-sectional area. Here the pressure PATM and here the pressure PATM. And what else they gave? So at a height 0.15 meters below. So let's consider this height is 0.15 meters. This height is a 0.15 meters. And then what else is there below the tap is Z is 10 meter per second square. The cross-sectional area of the tap is 10 to the power minus 4. That means at the top, so the area A1 is given, which is 10 to the power minus 4 meter square. Fine. So then, so with the initial speed, so the V1 is also given, which is 1 meter per second. Done. Chalo. So then, how do we find the cross sectional area here. So here we have to find the cross sectional area. So the simple thing, first equation of continuity you apply. Equation of continuity. So from the equation of continuity I can write, so the A1 V1 is equals to A2 V2. So what is the cross sectional area? A1 cross sectional area A1 10 to the power minus 4 into velocity V1. So 1 meter per second is equals to, so the cross sectional area A2 we have to find. We don't know what is the V2 velocity as well. So let's write the V2 velocity. So how do you find the V2 velocity for the TAP questions? Directly you can apply this concept. For TAP questions, so you can apply the, so the V2, so let the velocity here it be V2 and the cross sectional area A2. Yes, so then I can write V2 square is equals to V1 square plus 2GH, right? What is V1? 1 whole square plus 2 into G. They asked us to take 10 in the question into, so at what height they are saying? 0.15. 0.15. So I'll write 1 plus 2 into, so 10 into 0.15 is 1.5. So this comes out to be 3. 1 plus 3, this is total 4. 2 into 1.5 is 3, right? So 3 plus 1, 4. So I got V2 square is 4, not V2 square. So from here V2 is equals to 2 meter per second. I got the velocity V2. So simply substitute it here so that you get the cross sectional area. So we get 10 to the power minus 4 into 1 is equals to A2 into what is V2? 2. So then this is 1 by 2 if it comes this side. So 0.5 into 10 to the power minus 4. So check the options. 0.5. So it is in 5 into 10 to the power minus 5 I can write. 5 into 10 to the power minus 5 meter square. So option 3 is the correct one, guys. So this is the cross sectional area A2. So for the TAP questions you can directly follow this equation. To find the velocity at some height. Okay, so the V2 square is equal to V1 square plus 2GH. So no sir, I'll follow the procedure only. So you can follow the same procedure. Again at the end you'll get the same equation here. Okay, so this is the standard procedure for the TAP questions. This slide you can take it as a standard procedure for the TAP questions. Done? Chala, good. So this question also done. So let's move to the next question. So here what's the question says? Air streams horizontally past an airplane. So the speed over the top surface is 60 meter per second and that under the bottom surface is 45 meter per second. So the density of air is 1.293 kg per meter cube. The difference in pressure is, then the difference in pressure is, yes. So this is also the standard type of questions. So first understand the concept. Let's suppose this is a airplane wing. So consider this is a airplane wing. So for the airplane wing, the pressure, where the pressure should be more? So to fly, obviously the pressure at the bottom will be more, guys. So understand the concept first. See, so they said the speed over the top surface is 60 meter per second. So let the speed here V1 60 meter per second. And so the next, the speed here, so the V2 speed here is equals to 45 meter per second. 45 meter per second. Yes. So wherever the speed is more, the pressure will be less. Here the velocity is more on the top, so the pressure will be less. And at the bottom of the wing, so the velocity is less. Compared to this, the velocity is less, so that the pressure will be more. So the bottom of the wing, the pressure is more. At the top, the pressure is less. So as a result, what happens? So the aeroplane will get the upthrust. Yes or no? So it will experience an upthrust. So the pressure difference is there, delta P. How much upthrust it will experience? So that pressure difference into the cross sectional area will give the upthrust. Yes or no? Or it will experience as a force upward. As the pressure difference is there, so it will experience as the force upward. Yes? Chal. So but here they are asking only the pressure difference. So let's apply the concept. So the first thing is, so can we directly go for the, what's that? Bernoulli's principle. What is the, can we directly go for the Bernoulli's principle here? So first, you guys can solve this, I guess. Write the Bernoulli's principle formula. Here the pressure difference is there. So but height here, so is considered almost same, because here H1, because the airplane width is negligible compared to the height from the ground. So the height is going to be negligible. The width of the plane wing is negligible. So the height you can cancel out. So the formula that we can actually write for this questions is P1 plus half rho V1 square plus rho G H1 plus is equals to P2 plus half rho V2 square plus rho G H2. Yes or no? Yes. So here for the plane wing, the height H1 is equals to H2 is equals to almost same horizontal level. So then you can cancel this and this. So we have got P1 plus half rho V1 square is equals to P2 plus half rho V2 square. So then substitute the values here. Simply substitute the values. So where the pressure will be more? So at the bottom, let the pressure here it be P1, let the pressure here it will be P2. So we have to write P2 minus P1. P2 minus P1. I brought it to this side. So send this part to that side. Half rho V1 square minus half rho V2 square. Half rho V2 square. So that's it. We need the pressure difference only, right? So the P2 minus P1 is equals to, so take half rho out. So then I'll write here V1 square minus V2 square. V1 square minus V2 square. So then half into, so what is rho? Density is given in the question in kg per meter cube. So it's given for the air 1.293. So I'll consider approximately 1.3. Okay. So I am going to consider it as approximately 1.3. 1.293 means I will take 1.3 approximately. So what is V1 square? V1 square is 60 on the top surface, and at the bottom surface it is 45 square, right? So then I get half into 1.3 into, so this is 60 plus 45 and 60 minus 45. A minus B into A plus B, right? A plus B into A minus B. So 60 plus 45, so which is 105, and 60 minus 45, which is 15. So then I can write here, so do the calculation, 7.5 into 1.3 into 105 into 7.5. So how much we get here? Approximately, so close options are there? Options, sorry, here only, na? So I can choose the option. Okay, so let's calculate. So first let's write 7.5 into 1.3, so which we get 15, 21, 22, and then 5, and then 7. So which comes out to be 5, 7, 7. So which is 7.75. So 7.75 into, I need 105. So 105, I'll write here. 105 into 7.75, right? So 25, and then 0, 2, 5, and then 35, 0, 3, 7, and then so 35, and then 0, 3, and then 7. So this comes out to be 5, 7, 8, 13. So 10, 11, 8. So something around, so how much, after how much? 813.75. So 813.75. So the closest option, so I'll approximately take this one, 1018 pascals. Okay, so the calculation is correct only, right? Hopefully. Okay, so do the approximate calculations. We get it approximately, so 1018 pascals, guys. So the half into, yes, 7.5 this one into, so 105 into 1.3. Yes, so something around 1000 only we get. Something around 1000, so which is 1018 pascals, correct only. Done? Clear, guys? Chal. So let's go for the next question. Air streams horizontally past an aeroplane wing So of surface area 4 meter square. So the speed of air over the top surface is 60 meter per second. Under the bottom surface is 40 meter per second. So the force, see here what they are asking, the force of lift on the wing. So in this questions, the force is nothing but pressure into area, right? So the force of lift on wing, the force of lift on wing is equals to, so pressure into the area, the cross sectional area. Yes, chal. So then, so this is a wing. So where the velocity here v1 40 meter per 60 meter per second in the question they gave, and the under bottom surface is 40 meter per second. So wherever the velocity is less, the pressure is more. Let the pressure P2 here, let the pressure P1 here. So the P2 will be more than the P1. So P2 is greater than P1. Done. So then, so there is a pressure difference. So I'll write, first I'll find the pressure difference. So for the wing questions, what we can take? So the P1 plus half rho V1 square is equals to P2 plus half rho V2 square. Half rho V2 square. Yes. So the pressure P2 is more. So P2 minus P1 is equals to half rho V1 square minus half rho V2 square. That's it. So this is the pressure difference. P2 minus P1 is nothing but the pressure difference. P2 minus P1 into half into, so what is the density of air? They asked us to take 1 here. So half rho you can take out. So V1 square minus V2 square, right? So then do the calculations. So we get, so the P2 minus P1 is equals to, so half into, what is rho? The density 1 into, so this is 60 square minus 40 square. 60 square minus 40 square. Done. So 60 plus 40 into 60 minus 40. So which is nothing but half into 1 into 60 plus 40, 100. 60 minus 40, 20. So 2 ones are 2 tens are. So that we got 1000 is a pressure. So then what they are asking in the question? So force of lift. So the force of lift on wing. The force of lift on wing is equals to, so the pressure into A. The pressure into the area A. What is the pressure? What is the pressure? We got the pressure difference 10 to the power 3 I am writing. And what's the area? 4. Or else write 1000 only better. So 1000 into 4 area. So which is 4000 newtons. So 4000 newtons. Option 3 is the correct one, guys. Done. Everyone clear with this? Chal. So next we have one more question. So let's try this question. So a wind with 40 meter per second blows parallel to the roof of a house. So consider this is a roof of a house. Consider this is a roof of a house. So now the wind flows parallel to the roof of a house. So the area of the roof is, so 250 meter square. The area of the roof is 250 meter square. Fine. So assuming that the pressure inside the house is atmospheric pressure. So the pressure inside the house, the pressure inside is the atmospheric pressure, which is P atm. Done. So atmospheric pressure. The force exerted by the wind on the roof. So what is the force exerted by the wind on the roof? So and the direction of force is. So obviously, so here some velocity is there. Here this is V is the velocity of wind. Velocity of wind. So and inside the velocity is 0. Inside we can consider the velocity is 0. So that means upper velocity is more. So below the roof there is no velocity. So that means the pressure at bottom will be more and the pressure at top will be less. So as a result, so the force will be exerted upward. So the force will be exerted upwards. You can first cancel two options. Option A and option 4 are cancel. 1 and 4 options you can rule it out. because the force acts upward. How much force that acts? The force exerted by the wind. So in this particular case, I can write the force exerted by wind is equals to, so the pressure into the area A. The pressure into the area A, right? So what is the pressure here? What is the first change in the pressure shall we find? So let's apply the roof width is considered as negligible. So it is at the same height. So I can write, so the pressure P1 plus half rho V1 square is equals to the pressure P2 plus half rho V2 square. So then what's the pressure on the top? So let it be P1. Let's write or else. So the P1 minus P2, let's write. Not P1. P2 minus P1, because the pressure at the bottom is more and the pressure at the top is less. So P2 minus P1 is equals to half rho V1 square minus half rho V2 square. So I can take this term as 0. Why? Inside the velocity of the wind is 0. Done. Chalo. So then the change in pressure or the pressure change is equals to half into, so the density of the air they considered as half, 1.2 in the question. So what is V1? So V1, so 40 square. So 40 square means 1600. So which we can write it as 2 ones are 2, 800. So then you can cancel 0, 12 into 80. So 12 into 80. So which is 960 newtons. So this is 960 pascals is a pressure difference, or Newton per meter square you can write. So then what we required? The force exerted. So simply the force exerted, the force will be equals to, so the change in pressure into the cross sectional area. So what is the change in pressure? So 960 into, so what is the cross sectional area? 250. So chalo. So let's do one thing, guys. So 960 into, so 250 I am writing 1000 by 4. So then 4 ones are 4, 24, 240, and then so we get 24 into, this is how many zeros? 10 to the power 4, or 2.4 into 10 to the power 5 we can write. So 2.4 into 10 to the power 5 newtons. So which direction? 2.4 into 10 to the power 5 upwards. So downwards is not possible. Okay, so 2.4 into 10 to the power 5 is the correct answer. Done. Understood the concept? So for the wing, aeroplane wind questions and tap questions. So from the fluid mechanics, fluid dynamics, so the questions can be framed from these topics. Okay, so you guys should focus on this type of questions, very important, because that's why I'm taking much time and explaining these questions. In the tap questions, what you should consider? So the pressure at the top and the pressure at the bottom is nothing but same. It's a pressure constant, which is nothing but the atmospheric pressure. And the Bernoulli's principle will become half rho V1 square plus rho GH1 is equals to half rho V2 square plus rho GH2. And in the case of aeroplane wind questions, so the width of the wing is considered to be negligible, so that the height, the potential energy terms on either side can be cancelled. Okay, so P1 plus half rho V1 square is equals to P2 plus half rho V2 square. And one more thing, wherever the velocity is more, the pressure will be less. And wherever the velocity is less, the pressure will be more. For the aeroplane wind, so the velocity at the top surface will be more and velocity at the bottom surface will be less. As a result, the pressure at the bottom will be more and the pressure at the top will be less. So there is a pressure difference. Yes. So as a result of pressure difference, we get the upthrust, or there will be some force which is acting on the wing. Yes. So that's why it flies. Clear, guys? Understood? Sure. Good. So now let's go for the next concept, that's called the venturimeter. So let's go for the new concept, that is the venturimeter. So what's a venturimeter? It's a device which is used to measure the rate of flow. So it's a device which is used to measure the rate of flow. It measures so the rate of flow. Okay, so the venturimeter is a device to measure the flow speed of the incompressible fluid we are talking about. So the ideal fluid, incompressible fluid, whose density will not change, right? So this is the venturimeter, where here the cross sectional area is more and here the cross sectional area is less. Okay, so what we have to find? So the cross rate of flow. So here what we have to find, actually the rate of flow we have to calculate using the venturimeter. What is rate of flow, sir? Rate of flow is nothing but A1 V1 is equals to A2 V2. So A1 V1 is equals to A2 V2. So wherever the area is more, the velocity will be less, and wherever the area is less, the velocity is more. So in this particular case, if you observe, the area A1 is greater than area A2. So two areas we are considering. So one is a larger cross sectional area and this one is a smaller cross sectional area. So here area is more and here the area is less. As a result, so the velocity, area is more, velocity is less here. So velocity at V1 is less than that of the velocity at V2. So wherever the velocity is less, so the pressure will be more. So the pressure at P1 will be greater than the pressure at P2. A1 is greater than A2. Yes or no? So A1 is greater than A2. So if the cross sectional area is more, so the velocity will be less. Yes or no? So at A1 greater, right? Yeah, cross sectional area will be, velocity will be less. So V1 is less and V2 is more. So if V2 is more, so then the pressure at P2 will be less and pressure at P1 will be more. That's what. So that's why here the pressure is more, here the pressure is less. So it raises to, if the liquid is flowing in this venturimeter, so you can say that, so some height here, it raises to some height H1, it raises to some height H2, and this is a height difference. So this is H1 and this is H2, so which we can write it as H1 minus H2 is nothing but H. This H1 minus this H2 is nothing but H height. Done, guys? Clear? And so this is the first thing. And in the venturimeter, so it is, these two are at the same horizontal level. So these two are at the same horizontal level. So the same horizontal level. So if they are at the same horizontal level, so can we write, so the equation, so the half, P1 plus half rho V1 square plus is equals to P2 plus half rho V2 square. Why? The potential energy term on either side will get cancelled. So the heights are same. This is at some height and this is at some height, same height, H. So then, so where the pressure is more? Where the pressure is more? So the pressure at P1 is greater than the pressure at P2. So the pressure difference P1 minus P2 is equals to, so P1 minus P2 is equals to half rho V2 square minus half rho V1 square. Right? So chalo, so I can write P1 minus P2 is equals to half rho if you take out. So V2 square minus V1 square. So V2 square minus V1 square. So this is a concept. So this is the second result. So the first result, the equation of continuity is valid. A1 V1 is equals to A2 V2. Equation of continuity is valid because it's a incompressible fluid and the flow is a steady flow. So equation of continuity valid, and Bernoulli's principle is also valid, but at the same horizontal level. So we can take the pressure difference this way. And so one more thing, see. So let me write. So let me do one thing. See here. Here the pressure, let it be P1. Here the pressure, let it be P2. So how do you find the pressure P1 and P2 here? Let this height be H1. Let this height be H2. So here H1 minus H2 is equals to the height H. The H1 minus H2 is equals to height H. So let me write one more equation. So the pressure varies vertically. Here it raises to some height. Here it raises to some height. Here pressure is more, right? It raises to more height. Here pressure is less. So here it raises to some less height. So then see here. So I can write the P1, the pressure at this place is equals to, let the atmospheric pressure is P0 here and let the atmospheric pressure is P0 here. So vertically how the pressure varies? P0 plus rho GH, right? So P1 is equals to P naught plus rho g H1. Here the pressure P1 is equals to P naught plus rho g H1. Done. And here at the P2 the pressure is equals to P naught plus, so it raised to a height of H2. So P naught plus rho g H2. Rho g H2. So then, so where the pressure is more? At P1. So I can write P1 minus P2. So let's see, subtract these two. So P naught gets cancelled. So rho g H1 minus rho g H2. Alright. So then the pressure difference P1 minus P2 is equals to rho g into H1 minus H2. Rho g H1 minus H2. So P1 minus P2 is equals to rho g. What is the height difference? What is the height difference between these two? So which is h. So this is nothing but height difference h. Right. So this is one equation. And then, so we have got, so this is one more equation. Sorry. So this is one equation and this is one more equation. Second equation. So now from 1 and 2 equations, from equations 1 and 2, so what I can write here? So on either side it is a pressure difference P1 minus P2 here, and here also P1 minus P2, P1 minus P2, yeah. So in the first case P1 minus P2 is half rho V2 square minus V1 square. Half rho V2 square minus V1 square, which is equals to, so rho GH. So rho gets cancelled. So send this 2 to that side. V2 square minus V1 square is equals to GH. Right? And then, so I can write V2 square is equals to V1 square plus, send this 2 to that side, sorry. So send this 2 to that side. It will become 2GH. So V2 square is equals to again V1 square plus 2GH. So any relation have you observed? Again the equation of motion, the equation, right, which is motion under gravity. So that means if we had to find the velocity here, V2, let the velocity here it be V2 and let the velocity here it be V1. So then V2 square is equals to V1 square plus 2GH. The same formula you can use it here in the venturimeter. Okay, so let me summarize for the venturimeter. So for the venturimeter, you can first write what is the equation of continuity. So the equation of continuity is valid. So the equation of continuity is valid. So what is that equation of continuity? So the A1 V1 is equals to A2 V2, and the venturimeter is used to measure the rate of flow. What is rate of flow? So the rate of flow is equals to, so A1 V1 which is equals to A2 V2. Done. And then, so in the venturimeter, so we can write, in the venturimeter we can write, so they are at the same horizontal level. So half rho V1 square plus rho GH1 is equals to half rho V2 square plus rho GH2. And then, so from here I can write like, so the half rho V1 square minus V2 square is equals to, so rho G into H2 minus H1, which is nothing but H. So half rho V1 square minus V2 square is equals to, so rho G H. Right? So this is one more equation that we can write. Done. Clear? Chalo. So and then, so the, to find the velocity at the smaller cross section, the velocity at the smaller cross section, let it be V2. So that V2 square is equals to, so I can write V1 square plus 2GH, where this H is a height difference between these two liquids. H is the height difference between these two liquids. Done. So this is about the venturimeter. Clear, guys? Done. Everyone? So just note this down and check the concept. If you want, you can write this also. The P1 minus P2 is equals to rho GH also you can write. From where it has come? Here. P1 minus P2 is equals to rho GH. So this also you can write. Done, guys? So and then, so the rate of flow, so formula you can also write this way. I'm not going for the derivation. Actually from these two we get this. So but I'm not going for the derivation, not required. So A1 A2 into 2GH by A1 square minus A2 square. So the rate of flow is A1 A2 into root over 2GH by A1 square minus A2 square. A1 is the cross sectional area, wider cross sectional area, and A2 is a smaller cross sectional area. G is the acceleration due to gravity. H is the height difference between the two liquids. That's it. Done? Clear with the venturimeter concept, everyone? Done? Chala. So let's take the simple question. So what's the question says here? So try to solve this question on your own, everyone. So the speed of water at x is 20 centimeter per second. So here let the point x is velocity v1, which is 20 centimeter per second. Fine. So find the speed of water at y. Okay. So if the difference in heights of the two columns, they already gave the difference in height of the two columns. So v1 they gave 20 centimeter per second. So which I can write it as 20 by 100 meter per second. Let it be. And then height they gave h, the heights of two columns, the difference in heights of two columns. So that means this height they gave. How much? So 2 centimeters. So which is nothing but again 2 by 100 meters. So then, so they are asking velocity at the y. So we can write the velocity at y, the direct formula is equals to the velocity at x square plus 2gh, everything we know, right? So what is velocity at x? So which is 2 by 10. So I can write 2 by 10 whole square plus, so this is 2 into g. What is g? 10. So what is h? 2 by 100, right? So then this is 4 by 100 plus, so here 0 gets cancelled. So then 2 into 2, 4 by 10. Yes. So 100 is the LCM. So this comes out to be 4 plus this comes out to be 10 times. So 10 into 4, 40. So which is 44 by 100. Done. So Vy square is equals to 44 by 100. So from here the Vy is equals to, so root 44 by 100. Right. So which is nothing but root 44 by, so root 100 is 10. So then root 44 value approximately I can take 6.5. Yes or no? So root 44 approximately I can take somewhere around 6.5 by 10. So this is 0.65 meter per second. 0.65 meter per second. So I can write, so 65 centimeter per second. So the closest option you can choose. So 65 means I can choose the closest option, 60 centimeter per second. The option 2 is the correct one. Done, guys? Everyone clear with this? Chalo. So next. So we have got one more question here. So hope you guys can take this question as a homework. So at least one question you should solve it on your own, right? So let's consider only one homework question. So the area of the cross section of wide and narrow positions. So this is 5 centimeter square and here 1 centimeter square. The rate of flow through the tube, rate of flow is given. So find the difference in height. Find the difference in height. H, find the difference in height. Height of liquid in two columns. Okay, that's a question. Done, guys? So you take this as a homework. If you're not getting, I'll solve it in the next session. So chalo, so that's it from my end. We'll meet in the next session. So till then, keep studying. All the very best. Bye.